Alright, so we've already talked about inequalities and how they are essentially a math statement that tells you that some variable is either greater than or equal to, less than or equal to some value. So if we look at this inequality, we have the statement that x is greater than negative 3. And so based on what you learned in the past, you know that this is greater than, not greater than or equal to, it's just greater than. So we'll go to negative 3, we'll create an open circle because it doesn't include negative 3, but it begins at negative 3, and x will be all values greater than that, which means that x can be any one of these numbers underneath this line, just can't be negative 3. At the same time, we have another statement down here where x is less than or equal to 5. So because it has an equal sign, I can put the line underneath and I can graph it to the left, because these numbers on the left of 5 would be all the numbers that are less than 5. And we color it in because it also includes 5. It can be equal to 5. If I were to combine these two graphs and basically put them on the same line, I would have an open circle at 3 and a closed circle at 5, and we were talking about all the numbers greater than negative 3, and we're talking about all the numbers less than or equal to 5. But when we're talking about this combination, this AND, right, I'm talking about all the numbers that are greater than negative 3 and less than or equal to negative 5. So right here is going to be the actual answer. These are all the numbers that are greater than negative 3. And less than or equal to 5. So basically, this graph of numbers is representing both of these conditions at the same time. I want all the numbers that are greater than negative 3, but at the same time I want all the numbers that are 5 or less than, and these are all the solutions except negative 3. It's not a solution because it has an open circle. So in order to represent this, I can write an inequality that says negative 3 and 5, and x is every number in between. Now your symbols are always going to go in this direction, but I'm just going to check my circles to double check my signs. I have an open circle, so no line underneath. I almost made that mistake. And then we have a closed circle, so I do need that line underneath. These are called ANDs, where they kind of come together. Now ORs don't. ORs have a unique situation where they're going to point in different directions. So let's look at this real quick. X is less than or equal to 0. Okay, so there's a closed circle on 0, and we go to the left. Now we have this condition, x is greater than or equal to 3. That's going to be a closed circle and go to the right. Well, if we combine them on the same graph, I can show x is less than or equal to 0, and I can also show x is greater than or equal to 3. Now this is a unique situation. It's different than the one above us because this is OR. So we have x is less than or equal to 0, or x is greater than or equal to 3. The OR represents that x can be either part of this set of numbers, or it could be part of this set of numbers. It's similar to how you might be at a lunch line and you have to either go on the left lunch line or the right lunch line. It doesn't matter which one, but it needs to either be over here or over here. So ORs give you options where you can either be a part of one solution set or be a part of another. Anything that's in the middle, like these numbers right here, these are not solutions because they don't satisfy any condition. They are not less than or equal to 0. and they are also not greater than or equal to 3. So the difference is an AND has two conditions, and you're looking for the numbers that meet both of them. We were looking for the numbers that are greater than negative 3, but also less than or equal to 5. Down here, we have a little bit of a larger net that we're casting. We're looking for any number that's less than or equal to 0 and any number that's greater than or equal to 3. There's only, so many numbers that don't fit this bill. Here are some of them. 1 and 2. Neither of these numbers are less than or equal to 0 or greater than or equal to 3. So when I go to a matching question like this, the first thing that I'm going to look for are whether or not it's an or an and. Ands can be written with the word and, or and can be written as one inequality. But ors will always be written as one inequality or another, one inequality or another. Ands can have the option of using the word and or using this one long inequality sandwich, so to speak. So I'm looking for x is greater than 4 and x is less than or negative 2. So looking at this, I know that greater than is an open circle because it doesn't have the line underneath, and this is a negative 2 closed circle. It's or, so I know they're going away from each other, so that would be over here, which means that the other or is going to be right here. Now as far as ands go, let's look at this one because I know that this one might be a little different. It begins at negative 2 with an open circle, and it ends at 4 with a closed circle. Pay attention to the symbols here. So it begins at negative 2 with an open circle, and it ends at 4 with a closed circle. So it begins at negative 2 open circle and ends at 4 closed circle. So this will go right here, which means this one goes up here. Take a minute to graph these, see how you do. But let's move on to solving them. So solving them requires you to do a couple of things. One is split the inequalities up. Split up the AND inequalities. The ORs will already be split up for you, but the ANDs will not. This is an AND inequality, and I can tell that because of the way that it's written. Right? You have one inequality here and another one there. It's like they're being joined up, just like you would join two sentences with the word and. Okay, it's a continuous thought. So split up the AND inequalities and then solve each separately. So what I mean by that is, well, you could do this in two ways. I'm going to show you how to split it and show you how to not split it. If I were to split it, I would take the left inequality and I would just kind of focus on that, and I would block out this inequality symbol and whatever's on the right of that. So I'm going to block that, and I'm kind of only looking at that, so to speak. So I can write that on its own. And essentially that is this inequality. If I cover up that less than 17, I'm just going to solve that on its own. So if I solve it on its own, now this becomes a basic inequality. I get negative 10 is less than n. Okay, now if I look at the right side, I just need to cover up the left result and the left inequality, and I'm just focusing on that right hand side. I have 9 plus n is less than 17. Okay, so this basically becomes another simple inequality. I'm going to solve that one, and this will be 9, 17. Wow, totally losing it this morning. Alright, so you have two inequalities. Negative 10 is less than n, and n is less than 8. Pay attention to the way that these symbols look. It's almost like we can bridge these two inequalities together, couldn't we? So we have negative 10 is less than n, but then n is less than 8, and we can basically build our answer that way. Now here's the other way to do it. So this is splitting them up. You're going to need to do this in more complicated inequalities, but for something where there's only variables in the middle, such as these, and this is kind of what you're going to see this here, you can actually solve these in one step as well, without splitting them up. Like, you can just do the whole thing at once. Now I prefer splitting them up because this will serve you better when you get to inequalities where there's variables everywhere. But right now we only have a variable in the middle, and if there's only in the middle, this is one of the easier end inequalities. We can actually solve this all at the same time and get the same answer. So let me show you. So you could subtract 9, but just like an equation or any inequality, you're going to need to do it on every side to keep it balanced. So we're taking 9 away from both the middle, the left, and the right. The whole reason is that we can cancel out the ones in the middle, and the left and the right will become some number. -1 minus 9 is -10. The symbol stays the same. We didn't do anything to make that change. N is still in the middle. And on the right side we have 8. Now, this is actually, for a lot of people, much simpler. And this is probably the method that you should go for this course, but in more complicated problems, you have to split them up. It just has to work like that. So we're going to graph this. Now, as you graph this, the left number will be the lowest number should be on the left. So if I look at my two numbers, I have -10 and I have 8. -10 should go first. It is the smallest number. Smallest numbers on the left, and larger numbers on the right. You don't need to put every single line out here. That's not important, as long as we recognize that there is one number here and a gap and another number there. And so n is every number in between, right? Let's just remember what this looks like. N is every number in between. Now look at the symbols. You need an open circle on -10, and you need an open circle on 8. And remember, this is an end inequality. This is an end. So that means that they come together. So all the numbers that are greater than -10 and less than 8 would be these right here. These are your solutions. Okay, give a shot on these and see how you do. See how you do.